So it says that it's complaining about it. So I'm now aligning the power steering pump. And then I'm going to go in and I'm going to align the power steering reservoir.
Welcome to the AI in Manufacturing podcast here on Industry 4.0 TV. I'm your host, Kudzai Manditereza, and today we will discuss AI copilots for manufacturing assembly optimization. And to help us dive into this topic, I'm joined by Zeesha Zia, who is the co-founder and CEO of Retrocausal. Welcome to the show, Zeesha. Thank you so much for joining us today.
Fantastic. Thank you, Kudzai. Great to be on your show. Yeah, it's a privilege. I watch a lot of the episodes that you put on, and yeah, it's fantastic. Great job at pulling off such an amazing podcast.
Awesome. Thank you so much. Thank you so much. So, I mean, before we kind of like start, could you begin by introducing yourself to our audience and tell us a bit more about your company, Retrocausal?
Absolutely. I'm Zeeshan. Like you said, I'm the co-founder and CEO of Retrocausal. We are based out of Seattle, Washington. I originally come from an industrial automation background myself. Much like you, I studied at the TU München, where you're locally, you're local to that space area now. Used to work at Siemens, building industrial automation systems. Systems that could read things like RFID and machine vision systems. I briefly worked at MVTech, GmbH. Actually, they sponsored a lot of my studies. MVTech is this company that spun out of TU Munich, and it's one of the world leaders in machine vision technologies. Uh, I did my PhD from the ETH at Zurich in Switzerland, focused on computer vision, activity recognition. That was, almost 11 years ago. I finished that. I taught at Imperial College London for a couple of years in robot vision. Then I moved to the US, worked in Silicon Valley for a couple of years, worked at Microsoft in the HoloLens division, and now at Retrocausal, right fitting with what your podcast is about. We build AI co-pilots for manufacturing assembly optimization. Have some of the largest manufacturers on the planet as our customers. We focus on discrete manufacturing and automotive OEMs, as well as part suppliers, on hardware assembly, on appliances, electronic assembly, and yeah, we are at this point about 80 people in the company. Yeah.
Wow, that's super awesome. I'm really excited to, explore this topic further with you today. So maybe let's kind of like start by painting a picture of the current status in manufacturing.
Oh, yeah.
Uh, from your perspective, what are the most significant challenges manufacturers face right now, and how do you see AI addressing these challenges?
Oh, yeah. I think that very few people would disagree that in manufacturing, the biggest challenge right now is labor challenges, labor shortages, to be more specific, or the shortage of trained labor. And that labor issue it's a multifaceted problem, but the bottom line is that manufacturers just can't find enough trained workers and engineers, or line leaders for that matter, and the people that they do find aren't qualified enough, and that leads to loss of revenue and poor quality and waste. Right, case in point, we recently deployed with one of the largest manufacturers in the med devices industry. And at that particular facility, it's the plant manager is running multiple lines, but one of those lines is a $50 million a year line, and that plant manager is losing about $8 million a year
Wow.
due to scrap costs. And these scrap costs are the scrap costs are huge also because they're in a regulated industry. They are regulated by the FDA, But essentially, the reason for those scrap costs are because over the last decade, they have more than tripled their temporary workforce. Right, the temporary assemblers there have more than tripled, and they tend to stick around for almost on about 3 months on average. So there's not enough time to really properly train them. And since they know that they are temp workers, they're not super motivated or to do a good job either. And essentially, what we help them do is we set up our systems that use computer vision to understand what workers are doing, what the current step of the assembly process. And if the worker is about to make a mistake, we offer an alert right there and then. And that helped bring down their scrap costs by about 90%. And so these guys manufacture these small devices that go into the human body. It's a camera that go into the human body to detect kidney stones, right? It's a $1,500 device. One device is $1,500, and they were running at 30% scrap rates. Workers will do a tiny mistake and they're not allowed to fix it because of FDA regulations. And we were able to help the workers avoid minimize those scrap rate costs. But then the other challenge was also that sometimes the workers, there is an experienced worker, but the process itself is not very mature, right? So because it's a line leader who's not a highly qualified industrial engineer, if you will, or if they have industrial engineers, they are overburdened. So essentially, there are line balancing issues. There are other kinds of issues around ergonomics, comfort, which lead the operators to do non-standard things. They don't want to pick up that bin from up there, and they'll pick up some parts, put them near them, and then they'll start working with those parts. And these kinds of non-standard things lead to making more mistakes, which in turn lead to quality issues. And I see the same pattern across manufacturers. They don't have workers, they don't have industrial engineers to do a great job.
Yeah, I mean that's super interesting, and I kind of like want to sort of like take a step back and sort of like look at the underlying fundamental principles when it comes to the reduction of waste in manufacturing processes.
Yeah.
And as you may know, kind of like over the past few decades, there's been many approaches as far as reduction of wastage is concerned, and one of the most prominent go-to strategies around that was lean manufacturing.
Yeah.
So my question is kind of like, does sort of like your AI optimization approach build on these traditional principles? And if so, what precisely role does that AI play in sort of like augmenting these traditional approaches?
Absolutely. So essentially, lean is all about. When you talk about lean, you'll hear lean practitioners often talking about trying to optimize for quality, productivity, and safety. Right? These are the three key uh, areas where lean helps you improve on. Right? Quality, productivity, and safety. Uh, we are not the only product out there, but I think I can give the best example out of our product, and I can give you other examples as well if you want. But we have three products, one for each, right? For quality, productivity, and safety. For quality, we have a product that we call Assembly Copilot. And essentially, Assembly Copilot is where you put a camera permanently at your station. We just do software. We are able to work with any kind of camera. It can be an inexpensive $30 webcam, or it can be a $25,000 microscope under which you're building these tiny medical devices. Our software will talk to any of them. You have a worker who's assembling a part. If the operator makes a mistake, the system offers an alert. It can be an alert on a display, which causes the operator to fix that mistake right there and then because it's real time. Or the system can be talking to other smart tools. For instance, through HiveMQ, we can be talking to your conveyor belt, and we can stop the whole conveyor belt. The system can lock and interlock so that the operator won't be able to move that defective piece over to, transfer that defective piece over to the next worker. That's what we do with Assembly Copilot, right? That's the first example of helping um, plant operations improve quality concerns. We also record, the system can optionally also record every videos of every cycle that's performed, and you can do video traceability for root cause analysis. You can have a bunch of analytics around time, how much time is spent, what kind of mistakes were made, again from a root cause analysis perspective, so you can improve your processes. But that's assembly copilot, where you have a permanent camera observing a process. It's using computer vision to understand individual steps of an assembly process. I'm happy to show you a live demo as well if that's something that you're interested in. But then the other piece is productivity, right? In lean productivity, it's work standardization, time and motion studies, line balancing, all those tools, continuous improvement. They're all very, very important. And we have a product that's called Kaizen Copilot that's aimed at productivity. What Kaizen Copilot allows you to do is, or let me take a step back. A lean engineer today, their job is they'll go to a workstation with a stopwatch and with a clipboard, and they'll try to do a time study. But time studies take a lot of time, because you have to observe the process, and while you're noting down the current step, the worker has already moved on to the next step, and you want to record at least 20 cycles to get a reliable time study out, and all those things. What we do is we allow you to put a smartphone up on the station. You mount it with a mount that you use in your car to do to play uh, Google Maps or something.
Yeah.
You record a video of 20 cycles, 30 cycles, one cycle for that matter. You upload it to our portal, to the Kaizen Copilot portal. You label just one of those cycles. This is where the cycle starts, this is where the cycle ends, and our AI does the rest. It will detect all the other cycles that are in the video. It will break all of those cycles down into meaningful assembly steps, and it will provide you with names for each of those steps. And then it will go in and it will further classify each of those steps as what kind of activity is taking place in here. Is it picking up an item? Is it just inspection? Are you walking around? And based on that, it will come to a conclusion of whether it's a non-value add, value add, or necessary but non-value add step. So we get you time studies really, really fast. And then you can import all of that into our line balancing module, which allows you to balance lines really fast within a matter of minutes and hours instead of in weeks. So that's basically, and we do things like mod apps, MTM, UAS, all the predetermined motion time studies as well. So essentially, we are helping you do improve productivity, minimize the number of the head count that is needed to do a certain process, minimize bottlenecks through Kaizen Copilot. And then coming to safety, for safety, we have a product that we call Ergo Copilot. And with Ergo Copilot, all you need to do is you again take out your smartphone, capture a video of a worker as they're doing a job, and the system will give you, it might be a long video, the system will point out risky intervals within that video and say, you know what, something risky is happening here. Why is the worker having to bend so much? So that, you might be a facility where you have 400, you might be an organization where you have 400 factories, and in the corporate team you have great EHS people, ergonomic health and safety people, but on those remote sites there is nobody to do ergonomic health and safety assessments. With AI, you're able to do those ergonomic health and safety assessments at the edge. And sure, there might be things that you still want to get the advice of your corporate EHS department on. You can reach out to them. So again, in summary, productivity, quality, productivity, and safety, assembly copilot, Kaizen copilot, and Ergo copilot.
Awesome stuff. Yeah, it will be great to kind of like see a demo of what that looks like in practice. But maybe before we sort of like jump into that, so you kind of like really done a good job of really outlining kind of like all these different core pilots that you offer, but kind of like to sort of like take a step back again to for 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 manufacturers who may kind of like have sort of like come across many different types of kind of like the word co-pilot, or many products that kind of like sort of like position themselves as co-pilots.
Oh, yeah.
What, in your view, how or rather would you define a co-pilot? What is a co-pilot, in kind of like what are the necessary sort of like features are required for kind of like something to be called a co-pilot?
Yeah, I'll start by telling you what a copilot is not. Right, a copilot is not an autopilot. Right, it's not meant to, or it's not capable of replacing a human, an individual. We, again, I've been a robotics professor myself. I don't think that robotics is at a stage where it can replace human operators. I don't think it's going to be at that place in 10 years from now. And we can, maybe controversial, we can dive deeper into that discussion. But a co-pilot, on the contrary, is something that helps humans become more effective at doing sophisticated jobs, right? Uh, in manufacturing, again, the idea is, how can you help a worker? The worker may be less trained, right? The worker uh, may be, again, in the, might be a slightly controversial, but if you go and talk to the smartest people in manufacturing, what they'll tell you is that in 10 years from now, robots will not replace humans, but pretty much every human operator will be a temp worker, right? So if
Yeah,
everybody is a temporary worker, how do you make sure that they're able to do a great job?
yeah,
How do you even run factories anymore, right? Some kinds of co-pilots can help these workers do a good job. So again, maybe a camera that's understanding the assembly process, guiding the operator through the process step by step. Maybe there are multimedia projections, AR, augmented reality projections, that tell the worker, hey, you have to pick up that part from that bin, right? Imagine a situation where it's a high mix process, right? On the same workstation, the worker is supposed to build 1,000 different part numbers, right?
yeah,
No worker can remember what they're supposed to do, right? If you have 1,000 different part numbers, or they'll be looking it up on a piece of paper, that will slow them down significantly. Maybe two part numbers are pretty similar. They're more there's more chances that they'll make mistakes. A co-pilot is something that's a, just like in the case of an airline pilot, right? Who's somebody who's there to assist you, right? Think of it as an AI assistant for the assembly line worker. Similarly, in the context of an industrial engineer or a line leader, think of it as somebody who helps them build and maintain better assembly lines, better workstations, right? How can I design this workstation such that my workers will be able to do a good job, right? You can maybe see that in my background, right? The system is suggesting that you should use a dual-sided bin setup, and that's going to make this process 12% faster, right? Maybe the industrial engineer that you have is too busy and couldn't come up with this on their own, and the AI is able to suggest this to them, and then they go, oh yeah, that's a great idea, right? Similarly in ergonomics, so for me, a co-pilot is like an assistant that increases the capability level of a human, allows them to do things that they previously couldn't. I think a calculator is a co-pilot as well. It's not an AI co-pilot, but a calculator is a co-pilot as well. I know you are an electrical engineer. uh,
yeah,
I'm sure that you couldn't pass your exams if you didn't have a calculator with you, right? You were doing a lot of these numerical calculations. Hey, calculate the current flow through this circuit, right? Or build this kind of an amplifier, and you had a calculator with you, right? But
yeah.
because you are using a calculator, that calculator is not the engineer. You are the engineer still, right? That's all a co-pilot is. And AI means that that co-pilot is powered by AI. In the past, there were some things that you couldn't build with traditional software development. Now you can do those. That's what an AI co-pilot is.
Awesome. Yeah, maybe this would kind of like be a good opportunity to sort of like dive into the demo and kind of like see
Oh
what
yeah,
that looks like.
of course. Sounds great. So I'm gonna show you a demo on that screen. Essentially, what you're seeing here is I'm showing the live camera view on this screen on the right hand side. So you can see me in that live camera view, obviously.
Yes.
Typically, in that part of the video, in that part of the screen, will be showing work instructions. So this is where the worker will see what they're supposed to be doing, right? But in this case, for the purposes of this demo, I thought it's better than I just show you the live camera view there. so that you can see what's going on. You'll
Yes.
see that as I start doing the steps, the system will track every step of mine using computer vision and AI, right? There's a display that's mounted up here that I'm able to see. There's also a stack light that shows me, that turns red when I make a mistake. And what I'm going to do for you is I'm also going to make some mistakes. Specifically, I'm going to do some steps out of order, and the system will show the mistakes in the potential issues window. Okay.
Okay.
So you're seeing
Awesome.
the current step. Background means that I'm not doing anything. Next step means what I'm supposed to do next. And potential issues shows you the mistakes that I'm doing. On the right hand side at the bottom, you see the elapsed cycle time. So it shows 0 right now. This means that I have not started the cycle yet. As soon as I start the cycle, you will see that the system will show you that I'm doing a cycle. I just turned off my background as well. So okay, let me start doing a cycle. The system shows that I should be installing the so-called crankcase breather hose. So I'm going to get right to it. I'm going to move behind the engine, and I'm installing the crankcase breather hose. As you can see, the system
Yes.
detected that I'm doing that step.
Mhm.
Now I'm supposed to go back and install the thermostat, and you'll see that the system will detect me doing that as well.
Oh wow.
So you can see that the system knows what I'm doing, and it's showing me the elapsed cycle time. So it's now measuring how much time is being spent, right? So now I'm on the clock. I'm supposed to be doing the next step and the next. I'm supposed to be installing the injection cable assembly now. So I do that. So again, it's basically checking what I'm doing. Next, I'm supposed to align the injection pressure sensor. As I do that, so it detected that I'm aligning it. I'm supposed to tighten them some small screws on it. So what I'm going to do is I actually supposed to have another screwdriver here, which I just lost. It requires a different kind of a screwdriver. So I'm just going to
Okay.
move on, and I'm going to do something else.
Oh yes.
And you
Yes.
will see potential issues that I didn't tighten the screw, right? So I'm just moving on, and I'm going to tighten something else. And you see that in the potential issues, it shows me that I was supposed to secure bolts for the sensor, right? It's
Ah.
still it's still understanding what I'm doing, but it thinks that I've missed a step. I have missed a step, so it says that it's complaining about it. So I'm now aligning the power steering pump. And then I'm going to go in, and I'm going to align the power steering reservoir, and so on and so forth. I could find the other screwdriver, and try to tighten that one, but it's going to take time from the demonstration. So I'll stop here. But you
Oh
get the
yes.
idea that essentially, I'm able to perform a live assembly task, and or actually, let my colleague is here. So I just got my other screwdriver. So I'm
Oh
going to
nice.
tighten that screw. And you see that the error message just disappeared,
Yep.
right?
The issue is gone.
Exactly, right? So I can keep going on like this. Obviously I can tighten. I'm supposed to put some screws in here, and then I'm going to just go, and I'm going to install the metal mount, and then my cycle is finished. You see?
Oh
So
wow.
now it's again at 0 cycle time, or the that cycle is complete, and essentially that's the demo, really.
Oh wow. Wow.
Yeah.
This is really incredible stuff. Yeah. I mean, thank you so much for for that demo. That was kind of like really, really incredible and painted a very clear picture of exactly what it means, this idea of a co-pilot. And what kind of like really stood out to me was the power of that visual intelligence, right? Being able to really identify what the worker is doing right now and be able to automatically sort of like move on to one step to the next, and then also identify if they didn't sort of like perform a specific task correctly. This is this is really incredible stuff, and I can see how that kind of like really. So when you mentioned those gains, I think you mentioned something about 60% or 90% gain at some part when you started the conversation. And I think it's clear to me how that could be achieved now just by kind of like looking at the Copilot in action. So that was really, really great stuff.
No, yeah, I appreciate it. Essentially, so that was just the assembly copilot piece. I like talk. It's a little bit more physical because I can actually show you an assembly process in real time. So I walk you through that one. Obviously, we can talk about Kaizen Copilot and Ergo Pilot as well some other time. They are a little bit more software like software demo. So it's a little bit boring. So I could upload a video there, but essentially, what you saw here is there's a display that's in front of me that's showing me what I'm supposed to be doing, or that display could share the space with a the display for an MES where the worker accepts a work order and then they start seeing this display. They can be like I said, we could be talking to a Hive MQTT, Hive MQ that could be locking in that conveyor belt that the engine might be on if I make a mistake and if I don't fix a mistake. So those kinds of things help you. But then if you just want to analyze the station, you don't want to have permanently a camera there, you could just as well just take your smartphone, capture a video of the whole process, upload it to Kaizen Copilot, and it will do an analysis and it will tell you how to improve the process itself. Maybe I'm bending too much to pick up some part, right? Or maybe I'm stretching too much to pick up some part, and it will tell me, hey, you know what, you're wasting time in here. Maybe the worker should be trained in this and this way. But absolutely, I enjoyed it as well.
Awesome stuff. Yeah, so I think maybe kind of like this is a good segue to kind of like talk about um, what are the typical, setups or steps. So, for example, when a manufacturer decides to implement one of your co-pilots, what does that deployment process look like? Can you walk us through the typical setup steps?
Of course. So, for again, like I said, we focus on quality, productivity, and safety. For productivity and safety, if all you care about is, doing fast kaizens, fast, improving your industrial engineers' time, improving your EHS specialists, right, ergonomic health and safety specialists, their performance, you can set it up in, in a minute. So essentially, we create an organization for you on Kaizen Copilot or on Ergo Copilot. You can then log in. You can upload your videos. You can literally use your ordinary smartphone cameras to capture videos. You can start analyzing within 1 minute, right? So we sign a deal and we are able to set things up right away. It's a web-based interface, so everything works right out of the box. The demo that I was showing you, that's Assembly Copilot. There, essentially, what you need to do is you need to set up a camera, right? It can be a, a USB, cheap USB camera. It can be a PoE camera. You need to have a Windows computer there as well that will be, doing edge processing. And essentially, you typically need to record a few dozen cycles of the assembly process that you're interested in. That's kind of the median case. In some cases, you might have a highly standardized process and you can do with just one cycle. In some case, you might have a pretty ad hoc process where a lot of complicated things are being done, and there we might need 100+ cycles. So we need that kind of training data. You upload that to our portal. Either we can train a model for you, or you can train it yourself using our no-code platform within Assembly Copilot. But essentially, that process can take, if it's a highly standardized process, it can be done in a matter of hours. So you just install the right software on Windows, you have the right camera connected to the system, to the laptop or the desktop, and you're good to go, right? You set it up in our software, you specify where the bins are, you specify where the regions of interest are. The system automatically understands how the hands are moving, how screwdrivers are moving, how other parts are moving, and you can define steps on top of that. Or if it's a more complicated process, it may take, you have to record those dozens of cycles, in some cases 100 plus cycles. That might take a couple of days, but overall it can take, like I said, for assembly copilot it may take you anywhere between a couple of hours to a couple of days to actually set it up. You'll typically need some amount of training data, video data of the actual process taking place, so the system knows what it is supposed to capture and understand and track, and the system can build a machine learning model for that system, for that process. Essentially, so that's how you do assembly copilot. With Kaizen copilot and Ergo copilot, you don't need to train a machine learning model. You don't need to train over your data. Everything is already there. The foundation models are already built in. We have a foundation model of our own that's called Lean GPT. It's backed by 7 granted patents by the USPTO, and you can deploy right away within a matter of minutes.
Yeah. So I mean, you mentioned kind of like there's this option of either you train the model for the customer, or they do the training themselves using the no code platform. So just kind of like get a sense of how much of machine learning skill or data science skill is it required to really operate your no code platform if they decide to train it themselves.
Oh, zero. You don't need any kind of background in machine learning or data science at all. It's a completely graphical user interface based setup that you use. Uh, Basically, again, we have, in fact, if I didn't talk about why I started Retrocausal in the first place. One of the key insights was exactly to build that kind of a platform. So I used to work at Microsoft in the HoloLens division. HoloLens, I don't know if have you had a chance to play around with HoloLens?
No, not yet. No.
It's just head-mounted augmented reality goggles that were focused on frontline workers, right? You might have heard about Oculus, which is more for
Yeah.
gaming. You might have heard about Vision Pro, which is more aimed at household usage. HoloLens was focused on frontline workers, right? And I was a lead scientist in that team, and essentially a use case that I constantly saw was a lot of large enterprise partners were using it, but they didn't want to have to hire data scientists and computer vision teams and write that code because it's really expensive, right? And
Yeah.
oftentimes that data scientist is somebody who doesn't have actual floor understanding, floor level understanding, right? So that's actually a patent that was granted to us like 4 years ago at Retrocausal. So this is one of the things we started working at the very beginning, about 6 years back. So essentially it's a no code platform that anybody can use. You need about an hour worth of training from us, and then you're good to go.
Awesome stuff. Awesome stuff. So I mean, as you kind of like already sort of like alluded to, I mean, like a huge, percentage of existing manufacturing infrastructure, to a large extent, still like legacy OT and IT systems. So, how do your sort of like Copilot integrate with these existing systems? I think you mentioned already that kind of like you use sort of like either MQTT or different protocols. Can you speak to us about the different integration mechanisms that you use to kind of like connect to different kinds of systems in a manufacturing environment?
Absolutely. So essentially, we in manufacturing, if you have a standalone system, it's useless. There are a lot of OT systems. You cannot run a manufacturing floor without a lot of technology, and if that technology is not talking to each other, then it's useless. We recognize this very early on, and uh, we basically support pretty much every fundamental protocol that's spoken on the factory floor, right? MQTT is one of the first ones that we implemented. We have OPC UA as well, so we talk to obviously HiveMQ. we talk to Ignition, we talk to Kepware. Uh, we have tested our system with more than 3,000 smart devices, right? So as far as actual tooling is concerned, smart tooling is concerned, PLCs are concerned, we have tested it with everything from, Allen Bradley, Siemens, all those kinds of PLC tools as well. We've actually deployed it with in a lot of those kinds of settings. So we support those protocols that allow, again, in the graphical UI, you're for instance, if you're using OPC UA, in our graphical user interface, you can within a few clicks define a tag that will be issued for a certain event. So in the demo, I showed you that I missed those, tightening those two sensor, the screws on the sensor module, right? You could, in the UI, you can just as well go and you can define two events corresponding to that, one event corresponding to that step. And at that step, a certain OPC UA tag will be issued from that edge device. And then you might have a PLC that's listening for that OPC UA tag. And as soon as it listens to it, it stops the line, right? Or it turns on a stack light or something like that. So we make it really, really easy to talk, because we speak these universally spoken languages. MQTT is amazing. A lot of smart tools speak it. A lot of other IT OT infrastructure speaks it. OPC UA is similar. So that's one part of our integration strategy. The other part is, for a lot of smart tools that are commonly used, we just provide plug and play functionality. So barcode scanners, you can just plug into that right edge device directly. You can have a lot of different kinds of stack lights. We just talk to them directly. We don't even need any other protocol in between. You can just set it up with our UI directly. You can set up a multimedia projector with our UI directly as well. So essentially, there's a multimedia projector that's projecting work instructions, that's telling you what to do, and as soon as you do it, the system moves on. I've seen some other tools where you are expected to tap on a table to make the experience move on to the next step, or the experience is really highly standardized. We don't need that level of standardization. The system will just track whatever. So you can have barcode scanners, stack lights. You can have a lot of different kinds of torque drivers. You can have multimedia projectors, a bunch of things that just work plug and play with our system. So that's kind of the second pillar. So every piece of tool that we are seeing is as being utilized a lot, we'll just pull it in and we'll start using it. We'll start providing you with plug and play functionality. And then as far as IT is concerned, we talk to obviously a lot of MES systems, which is kind of at the intersection of IT and OT. We are an official partner of Siemens Ops Center Execution Core. So if you're using Siemens, plug and play will talk to your MES system. The worker selects a certain work order, and that work order will go straight into assembly Copilot, and the system loads the right kind of instructions, the right kind of machine learning model, and there you go. Similarly, you can fetch in analytical data that I didn't talk about, or video data, and fetch, inject it directly into Siemens Ops Center Execution Core, right? We have implemented integrations with Factory Talk. We have worked, Rockwell Automations. We've also worked with SAP. So we have some ready to go integrations, and we also have a services team that will go into a customer site. If they have a homemade MES, we'll integrate with that as well. And then on the pure IT side, we have integrations with a bunch of different kinds of uh, SSO, single sign-on platforms, Azure Active Directory, Okta, Ping, all of those we support. We support a number of different kinds of InfoSec-related tools like, IBM QRadar that you need for InfoSec logs, so that you can get log information. We are an ISO 27001 certified organization. We have our final steps, working towards our final steps of GDPR as well. So we implement all of those InfoSec related IT tools within our platform as well. But those are three pillars. We speak a bunch of universal languages like MQTT, like OPC UA. We have a bunch of plug and play tools, and we talk to all kinds of different IT infrastructure that you might already have.
Awesome stuff. So I mean, if there's a manufacturing leader who's kind of like watching or listening to our conversation, but more importantly, kind of like watching you demonstrate kind of like on that specific workstation, and maybe they're thinking to themselves, well, maybe this is simple enough because it's a small contained deployment, and they're thinking, wouldn't it be a challenge for me to scale this out into like every work center,
Yeah,
different production line, and maybe across multiple factories?
yeah,
Can you speak to us about how easy it is to kind of like scale your solution out into,
yeah.
all part of the production environment?
Absolutely. Look, we have at least 13 customers where we are deployed on more than one factory, right? Where we are deployed across multiple, we are deployed at two or more factories with at least 13 customers. And again, I don't count POCs as deployments. I know a lot of companies would count POCs as customers. I don't think POC is just a proof of concept. I'm actually talking about deployments after a POC, right? Where we are deployed across multiple lines, across multiple factories, right? And then there's a long list of customers where at the moment we are deployed on factory number one. And then there is an even longer list of customers where we are at the POC stage, right? Amongst some of those multi-site customers, we have two of the top 10 automotive OEMs. We have two of the top five automotive part manufacturers. We have two of the top 10 three of the top 10 med devices manufacturers. You have the world's number one HVAC system, heating, ventilation, and air conditioning manufacturer, a couple of others in that list as well. Scaling is really, really simple because everything happens through one dashboard, web-based dashboard. You deploy these individual computers. If you are talking about assembly Copilot, you deploy individual computers, or you can have one computer in a data center in your computer center, and that can be talking to those cameras. You could deploy, for instance, PoE cameras, right? Power over Ethernet cameras, which are more common actually, and then put the computer in your computer room or something, in your server room, and that computer can talk to all of those power PoE cameras. It's really, really simple. It's highly parallelizable. You can deploy it on multiple stations. In fact, our minimum entry point for Assembly Copilot is between 10 to 20 stations, depending upon the region we are working with. So typically, our deployments only happen when the customer signs up at least 20 stations to begin with. Right. So all of our deployments are typically scaled deployments. On the other hand, when it comes to Kaizen Copilot or Ergo Copilot, that is infinitely scalable because that's a pure cloud platform. Again, we can work out details if there is a customer. For instance, with our defense customers, we are doing on-prem as well. But otherwise, it's a cloud deployment. You can have 100 industrial engineers across 10 different sites going on with their smartphones and doing things. It's like Zoom or something like that. So it's just infinitely scalable. So scalability has never been a challenge for us. You talked about relatively contained engine that you were seeing there. We have deployed this on moving assembly lines where there are entire cars coming down the line. We have deployed this in, I can't name the customer. We've deployed this in Toulouse with a giant aircraft manufacturer as well. So these cameras are looking at entire wings of aircraft being assembled, right? So spatial scalability, we can talk about spatial scalability, we can talk about infrastructure level scalability. And by the way, we have with the medical device manufacturer whose example I gave you at the beginning, we're looking at that tiny camera being built under a Leica microscope. So there is that, you can, in spatial terms, you can go really, really tiny. You can go at the scale of an aircraft wing, and on an infrastructure level, it's infinitely scalable.
Awesome stuff. So I know you've kind of like touched a lot on kind of like different example use cases for sort of like AI copilots in manufacturing. Do you perhaps have some real world example use cases that you want to sort of like share with our audience?
Oh, of course, absolutely. So, for instance, I'll give you the example of this auto part manufacturer that recently deployed us, Kaizen Copilot, that recently deployed Kaizen Copilot. And typically, again, it's a really, really large facility that they have, and they have seasonal variations in demand, and they have obviously worker absences, all those challenges, which is why they need to, they obviously have one set of lines, but when you have to produce less or more volume, or you have to put in more or fewer workers, you have to move workers around, you need to rebalance the line again and again. And for that customer, for this auto part manufacturer, they needed to, every time they do a line rebalance, it takes them about a week to do so, because they first have to do time studies on each of the stations, and then somebody manually goes on a piece of paper or on an Excel sheet and moves steps around and says, oh, you know what, yeah, this station is going to be balanced, and now there's not going to be any bottleneck. It takes about a week of time. We are able to do that repeatedly, in a very repetitive manner, very simply, in about 2 hours worth of time. So this customer, in fact, in the very first day when I went to this customer, I went there myself. We climbed up a ladder, we set up a camera, a smartphone, captured 20 cycles. Their cycle time is about 45 seconds. So we were able to do that in, whatever, 10 minutes or so. Then we climbed down, then we moved the camera to the next station, climbed up the ladder again, captured 20 cycles there. Another station, 20 cycles there. It's a six station line, that particular line, 6 worker line. And we came back to the meeting room, to the boardroom. We loaded those videos up into Kaizen Copilot. All of this, the recording part took about under an hour. We loaded it into Kaizen Copilot. The system broke all those videos down into steps, step names, time studies are out. We could export it out into the customer's preferred Excel format. We don't expect you to use our Excel formats. We can build your Excel formats. And then we were able to import it into our line balancing module, press a button, and boom, the system told you how you could run the same line with 4 workers instead of 6 workers, right? And they validated it over the weekend. They actually implemented that change. On Monday, they moved the other 2 workers to a different line, and that line was working with 4 workers, right? From 6 to 4. And they were able to do all the computation, all the documentation in 2 hours, including the data gathering part, right? Another customer we went to for Kaizen Copilot, this is a customer that it's a world leader. I can't, you'll probably guess them very quickly. They manufacture these industrial adhesive systems. And we went to one of their lines, and again, this is basically, they wanted us to increase their yield in their case, right? On the very first day, we were able to capture data, video data. In their case, they already had a couple of surveillance cameras mounted up there. The software Kaizen Copilot identified that 45% of the work that was happening there was non-value add. 45% of the work was non-value add. It immediately made a number of suggestions for improvement. The industrial engineers there and the line leaders were able to implement those improvements and go from 41% non-value add work down to 20% non-value add work. They actually implemented those changes again within the week. They had to train the workers a little bit and so on. The following week, they were up about 11% in yield. The first time yield went up by 11%, just like that.
Oh, wow.
And by the way, both of these customers, we are now deploying, in talks with them to deploy to 15 plus of their sites. So essentially, both of these customers will running all of their industrial engineering on Kaizen Copilot. I can keep giving you examples like this. Ergo Copilot, right? The Ergo Copilot, uh, there's a large manufacturer in the automotive part space. They have a small factory that's kind of remote and located somewhere remote. They have a very hard in that factory. It's ironically easy to hire workers, assembly line workers, but really hard to hire engineers. So their lead industrial engineer is somebody with a BS degree in marketing, right? And has done a couple of these Lean Six Sigma courses like yellow belt and those kinds of things. They deployed Ergo Copilot. Uh, Literally in a couple of days, they were able to, in the past they kept having these OSHA claims for MSD, for musculoskeletal disorders for certain workers. And this line leader or this industrial engineer who's not doesn't have a degree in industrial engineering, has no ergo training, was essentially able to go around, film a lot of workers doing their jobs, and identify almost a dozen different ergo risks, right? One of
Yeah.
those was the worker is pulling this large carts. It's a material handling worker. So the worker has to put these carts on a station every 20 minutes or so. She goes in, she will put these heavy parts, and then she will try to drag the part, that whole cart with her, kind of dragging it along her back. And her whole upper body is twisting as she's pulling it with one hand, because the aisle needs to be empty at all times. And she's having to, the parking spot for that cart is on one side of the aisle,
Yeah.
and the station is on the other side of the aisle. So she's bent, twisting her upper body. He had no clue that, yes, when somebody is bending, that's clearly a sign. You can kind of figure it out, right? He didn't think that that would be an ergo risk. Our system flagged it as an ergo risk and made a couple of recommendations that they were able to implement right away. And that basically brought their risk score for a number of their processes down by, I think, an average of like 95% or something, right? So again, I
Awesome.
don't think we have enough time. We can talk about how ergo assessments work, how the metrics work there, what the risk scores are. But our software allows you to quantify ergo risk, right? If somebody's bending, how much of a risk is it, right? And it's also able to give you design parameters. Hey, look, this is the recommended weight limit for this kind of an activity.
Oh,
So,
yes.
so they were able to implement a bunch of those. I hope that sort of makes sense. I can talk about a dozen of different, assembly copilot examples on moving assembly lines with an HVAC manufacturer. We have implemented it where workers were not able to put on the right sockets, the wires at the right sockets, and the whole thing will get assembled. And again, it's a jumbled mess. The whole thing will get assembled at the end. And now these industrial heaters, they test them, and turns out that it's not working. So they have to send these industrial heaters to a different room where they disassemble the whole thing, fix it, and so on, patch it. In contrast, they actually this with Hive MQ, they connected their conveyor belt with the system. If
Yeah.
there are these four stations where workers are supposed to connect these sockets, if they miss any of those, at the end of that fourth station, the line stops.
Oh,
They,
yeah.
they then have to fix it right there and then. Again, this is something that had some percentage points improvement in their yield, but actually surprisingly on throughput, it increased their throughput by about 25%. So that's a line that had a lot of backlog. There were a lot of back orders, and they are able to start filling those back orders much faster in the same floor space.
Amazing. Just amazing stuff. Really. I mean, to kind of like really sort of like close this sort of conversation today, I want to kind of like, I've got two questions for you that I want to tie in together. So, as you kind of like interacted with customers at different levels of maturity, maybe at POC level, production level, um, are there some sort of like common patterns or common mistakes, or rather, whether they be technical or cultural, that sort of like, are a barrier to adoption of
Yeah.
AI co-pilots? Just kind of like help manufacturing leaders who are on this call to kind of like, better position themselves to navigate this space, and also just second question, broadly speaking, what would be your advice to manufacturing leaders who are considering adopting AI co-pilots? Kind of like how should they approach this?
Absolutely. For the first one, I think the biggest challenge that I see is there are a lot of well-meaning middle managers, uh, who see the challenges on the floor and they want to fix them and they want to deploy technology. It's not just with AI co-pilots; it's with any kind of technology, really. And I think, and there's a lot in them. They want to improve the factory floor, but this is also good for their own careers. If they can show their impact, they can also rise through the career ladder. But the key challenge for them is uh, they don't understand their own internal buying process, right? They don't uh, how does their own buying process work? What are the things that the IT department is going to expect? Where does the economic buyer, where does your boss's boss, who's actually going to write the check, what are the things that he or she needs to see, right? What are the other stakeholders in bringing this technology onto your factory floors, right? There are always going to be other maybe HR needs to get involved, right? You need to, I would recommend manufacturing leaders or manufacturing middle managers who are trying to bring in new technology to understand and map out their own internal buying process as much as possible. Try to understand, go talk to people who have previously deployed technology within your own company, within your own factory, or within sister factories. I think that's going to, I see that as one of the biggest hurdles, because now we don't offer POCs, but back, a few years ago when we used to do POCs, one thing that would often happen is that, we would do a POC, we would have clear metrics identified before the POC started of what we needed to hit. We would hit those metrics. The customer would be seeing that, champion would see a clear ROI, but then the discussion will fall off there, because the champion sometimes didn't know how to navigate that internal buying process. So that would be something that I would really recommend aspiring manufacturing leaders to nail down. It's great that you're passionate about improving your processes. It's great that you're passionate about deploying technology. But if you don't know how your you know buying processes work, who are the stakeholders, that then you're going to have challenges, right? Or go talk to your VP level upfront and say, or plant manager upfront and say, hey, look, this is what are the metrics. If I can hit this, will you buy? Right? Is this
Yeah.
what is the your priority level for this sort of thing? Or don't pursue it if this is not going to be bought, right? If it's a waste of your own time, right? That's number one. Number two, if you are looking to go learn about AI co-pilots, again, I hate to do shameless self advertising, but the thing is, CB Insights came out with this advanced manufacturing 50 list 2 years ago. We were the only AI company on that list. They came up with 50 companies, advanced manufacturing 50 advanced manufacturing technology companies out of 6,000 that they looked at. We were the only AI company in there. Uh, CB Insights has a different list called AI 100. So 100 top AI companies that includes OpenAI, Perplexity, other kinds of companies. There are only four manufacturing technology companies there. Some are more like 3D printing, CAD modeling, so design side. We are the only process side company in there. I really think that come talk to us if you're interested in AI copilots. We already have a lot of the market cornered with our patents. We have 7 granted, 3 more pending. I think even if there are some other players that are out there that might be claiming to do something similar, there's a good chance that they are infringing our patents. But just come talk to us. Like I said, we cover the quality piece, productivity piece, the safety piece. If this is not it's not a good fit for us, we'll let you know. You'll find us to be the most transparent company out there. There are certain things that we don't do well, and I'll point you to the right company that you should go and talk to. I mean, there's a company I want to point out. Jensen Precast is a manufacturing. It's a construction. They're doing construction related manufacturing.
Yeah.
One of their leaders reached out to us, and for certain things, I said, hey, you know what? For these use cases, I really think you should be going and talking to XYZ company. A few weeks later, they came back to us and they said, hey, you know what? We really want to work with you guys. The way you do things, we'll see if we can integrate with that company as well. But and now we have a deployment across multiple sites for Assembly Copilot as well as Kaizen Copilot with them. So if you
Yeah.
want to do AI copilots, just reach out to us. More than happy to help both on the manufacturing side as well as on the AI side, or just geek out on the AI piece of it itself. So again, I come from a pure AI background. I used to be a professor in the AI space. I'm more than happy to just chat and maybe some office automation related stuff, right? Maybe you're not even interested in the OT piece of it. You're interested in the IT piece of it. I'm more than
Yeah.
happy to chat.
Awesome stuff. Yeah, so I mean, we'll certainly provide links to your website here for all those who want to reach out to you, and I'll also provide social media handles for your LinkedIn account and all the relevant material. So, do you perhaps have any last words for our audience today?
Oh yeah, you're doing a great job, and anybody who's listening in, I do think that AI is going to be a game changer in manufacturing. It's not about if you're not using AI in your processes, you're going to be left behind. I have no doubt in my mind. Just look at what we are doing, or just look at other companies that are doing interesting things. We are talking about boosting your industrial engineers efficiency by 5x on very measurable metrics, right? I'm not just speaking out some marketing bullshit. You can actually measure these things, right? You can actually measure the impact on yield, the impact on rework, and so on. And your competitors are implementing these AI solutions right now. So if you don't, you're going to be left behind, right? They're going to be bringing down their cost of poor quality significantly. They're going to be increasing their profitability. They're going to be increasing their, uh, reducing the number of product returns from their customers. Who's their customer going to buy from, right? So I think you're doing a great job, actually, calling attention to how AI is uh, through us, but also all the other people that you're interviewing, some incredibly high quality people. I can't emphasize enough that people need to watch your podcast, and I think the people who are watching it are also going to be actually leading this revolution that's going to truly revolutionize manufacturing. I think I can't imagine how you can run a factory without significant involvement of AI in the next 5 years, to be honest with you.
Oh yeah, absolutely. I mean, really also the goal for this podcast is kind of like really to position, because it's also clear, to me that this is basically where it's headed. If you're not adopting AI today, you're definitely going to be left behind
Yeah.
3 years, 5 years from now. So really the goal of the podcast is really to empower all of the manufacturing leaders to be able to kind of like really anticipate and see where all of this is going, and be able to kind of like get ahead of the curve and start implementing all of that technology now. So
Yeah.
thank you so much again, Zishan, for taking the time to join us today. It was really a very insightful session, and I hope our audience found it very educative. So thank you so much, and really appreciate your time today.
Thank you, Kudzai. I really appreciated talking to you. It was really fun.